Good morning, good afternoon, good night, wherever you're joining us from here for the Spatial Data Science in Financial Services Summit. This first edition of this event, but part of a broader and longer standing group of events called the Spatial Data Science Conference. My name's Flo Broderick. I'm from the CARTO team, and I'm really excited to be joining you here from my house. So would it be like to be joining you in person, as I'm sure many of us would across the globe. But it'd be a pleasure to moderate this event, which is taking place today and tomorrow. In this event, we're bringing together a wide range of spatial data science, analytics professionals, GIS professionals from the financial services industry, including credit card providers, funds, whether that's private equity funds, whether that's pension funds, banks, insurers, reinsurers, a very wide range of areas in financial services. And we're really excited to have a great speaker lineup both today and tomorrow. But without further ado, I'm really excited to introduce Matt Forrest. Matt Forrest is Director of Spatial Data Science here at CARTO. And he's going to be kicking off the day by talking about how you can use different spatial data science techniques to analyze retail investments, which of course is a very hot topic with the current situation in retail, with everything that's going on in the world and the way that our shopper experience is changing rapidly. So over to you, Matt. Thanks for joining us.
Yeah, thanks for having me, and great to meet everyone. Excited to be here. And yeah, unfortunately, we of course can't be in person, but I'm glad to be able to talk to everyone and meet people from all over the world as well. So like Flo said, my name is Matt Forrest. I am a part of the CARTO team as well. And I head up our spatial data science solutions team. And today we're going to talk about using spatial data in analyzing retail or physical asset investments, really. So I'm going to go ahead and share my screen. And once that gets started, we can go ahead here. So how do we understand and analyze retail investments, and how do we use spatial data to specifically do that? This is a topic that we get asked quite a bit here at CARTO. And really, when you break it down, we're looking at two different things. We want to understand, first of all, what are the attributes or things that draw people to one location versus another, and how do those features or sort of attributes impact the performance of those locations. And we kind of can look at this through the lens of retail. I think that makes, it kind of adds some different, context to it, and everyone can kind of understand the shopper experience, because we all go through it on a daily basis. We choose locations to go to and we decide where we're going. But ultimately, you can apply it to many different aspects. You can apply that to potentially real estate investments, other investments such as distribution centers, warehouses, any sort of physical asset. It's the same sort of properties that sort of make that up. So the key question we're going to be discussing today: performance of your physical assets and using spatial data. And what I hope to show you and talk about is that using spatial data correctly can add valuable insights, but only when exposed to key parts of your organization. And what I mean by that is, sometimes we can work in a bubble, and a lot of the work that we develop is seen by different teams. But it's very important to bring those insights out to different parts of your organization who you're working with, and let different people that are working on these decisions on a regular basis run those analyses and use that data to the best of their capabilities. So what we'll look at is what data and features matter to the performance of a physical asset. How do we find that data, and what features should we use? A few different modeling techniques that make sense to use for spatial data for a set of physical assets, looking at different models and things that you can use to understand that. How to apply that across some different financial services use cases and practices. And then finally, like I said, how do you productionalize this and bring it across your organization and make it useful to others that are working on these different problems in the field? So the first question, or first piece we're going to study, is using spatial data and asset features in combination to analyze performance. What are those features we want to look for? Where do we find them? And how do we use them? First and foremost, whenever you're analyzing a physical asset, you need to define your catchment area. And there's a lot of names for these. These could be catchment areas, trade areas, and there's a lot of different ways they've been defined over the years. So an example that you're seeing below here is actually looking at a physical asset in Seville, Spain. And we're looking at 3 different ways to define that catchment or trade area. On the far left here is your simple radius. It's a certain number of kilometers or miles around a physical location, and that's sort of the simplest way to say that is on a straight line distance, how can you reach that location? Now, while that may work for some use cases, generally we want to get a little bit deeper and study that in more detail. So in the middle panel here, what you're seeing is using a drive time. You could hear these referred to as isochrones as well, but essentially saying how within 5 minutes or a 1 mile drive, how many people can reach that location. Now, these make sense for different locations as well, but not everyone travels by car. There's also, you have to account for public transportation. You have to account for bike and walkings, and especially in these days, these drive times, while many times are applicable, they may work it may work in some areas and not others. So the classic example is in New York City, not many people are driving to these retail locations. They're either walking or taking the train or something like that. Whereas if you go to maybe a city like Dallas or Atlanta, a car is going to be the primary mode of transportation there. So how do you account for that, and how do you scale that? Well, traditionally, catchment areas were defined potentially by like a gravity model, and using that from like a survey data to sort of understand who and what's the draw to a different area. But in these days, we have mobility data, which is collected from cell phones and devices that are using your GPS and sharing that data to actually look at where your mobility is moving to and from. That's this one on the right, which is sort of we've drawn a polygon around a core set of visits to this specific location. And that gives us a real view of who's going to that location, where are they coming to and from. And ultimately, it doesn't matter about the mode of transportation. It's ultimately looking at who's there and what their device is. So any of these approaches are valid. It's not to say that any one is wrong. It's just figuring out what makes the most sense for your asset. The next is actually enriching with multiple data sources. And the key here is actually to go wide and try to enrich with as many data points as you can, because we're going to limit that later in the process. But this is another example with a simple drive time and looking at potentially road traffic that's coming through this location. The potential, this is a retail potential, as you're seeing the choropleth map underneath the isochrone here. There could be demographics or points of interest or competitors, and you get the idea. Is you want to start to bring in as rich with as many data streams as possible to start to capture and cast a wide net, because we don't know what's going to be impactful after that specific location, but we want to start actually bringing as much data in as we possibly can. Now, all that said, we've talked about spatial data, but we also understand the physical features of locations. And I'm kind of illustrating with a pretty simple example here, but here's 2 different McDonald's stores, and obviously they look very different, right? On the left is obviously a newer model. It's clearly, had, some upgrades and, it looks nice, right? if you're being just objective. On the right is what I traditionally grew up with as a McDonald's on the highway, one of the older models, and they just look different. How can you sort of capture that and attribute that? Well, if you are lucky enough to have that data to say if there's a remodel date, or even you have the data that says there's a specific type of store in the fleet, you can use that data. But if you do, you can also categorically collect this by looking at images, try to categorize the stores and pull that information in. So there is a value in actually understanding what these locations look like, because there is a high value in terms of someone driving down a street or walking down a street and seeing these different locations. This might make an impact in their choice to actually go to these different locations. And also trying to understand access, right? This is an example around sort of, how you could actually get to a location. So on the left, we have a divided road. I believe this is in Dallas, Texas, for a Taco Bell location, actually, how do we physically get to it? Well, if you're driving on the right side of this road on Greenfield Avenue, it's fairly easy. I can turn in to the right, I can get to the access location and get there quite quickly. Whereas if I'm on the left, I actually have to go around, go through this sort of U-turn process, go off to the other side of the road to actually get there. It's actually pretty complicated, where if I'm looking on the right here, I can access this location from either Lake Street or 3rd Avenue. And, it's actually physically, it's pretty easy to access. So there's a few different ways you can kind of access these things. And it's really important to sort of understand, in the built environment, how easy is it to get to these locations? Because that could make an impact, in terms of revenue. Now, when you're looking at trade areas and all the people that might potentially go to a location, that, in aggregate, that's going to be a huge driver of performance generally. But these smaller features or these last minute decisions that someone might make to actually visit a location are ultimately important as well. Time series is also really important, and specifically in terms of what we're going to be studying and how retail bounces back as the pandemic and starts to, hopefully wind down here and vaccines roll out. Economic sort of recovery is going to be a key theme. And what we're looking at here is some data from MasterCard in a specific location for a specific census block in New York City. And you can see what happened is that, over time, these were growing. We probably hit December here. This is a high retail and shopping area. So, we hit a high in terms of the holiday season. February, March hit, and effectively we didn't have as much recovery, and the sales there have gone quite low. So how can we use this historic data in terms of performance to start to understand how that's going to impact locations going forward? Because we're really entering an unknown where a lot of the predictable things or the data points we would rely on to tell us that this is a great retail location are going to change. And the best driver of understanding that is going to be looking at human behavior, which is going to be surfaced through data like how are people actually spending money in these different areas, how are they interacting with these retailers, and which ones are going to bounce back. And that's going to be a really key driver. And over the next year is looking at this sort of data, comparing it to the past, and understanding what that's going to look like. The next is actually understanding cannibalization and competitor overlap. And cannibalization has always been a difficult thing to sort of capture, especially with, sort of drive times and this, these traditional trade area definitions. Now we have, like I said, this mobility data. This is looking at an overlap from SafeGraph data to actually look at a competitor's analysis. We have a store here in, this is just in the Bay Area. And we actually want to understand, okay, how many competitors are in, or near the store. And this is a Costco location. And what you're seeing here is actually census block groups. The darker block, the block means that more people came to that location from that block group. And we can actually overlay that with the different, competitors that come nearby. So you see we have Target stores here, and it looks like there's at least 3 Target stores that are overlapping that into competitors, where if you had a simple drive time, you might be only catching one of those as a competitor. You can also use this to overlay from a cannibalization perspective to say, okay, let's, for example, this block group right here, there might be, 15 people that visit that location from that block group in a month, whereas, 10 might be visiting other locations. This data gives us a really granular view of, these trade areas and cannibalization and competitor overlap that just weren't accessible before. And it really provides some deep insight into what's happening there. Now, we talked about a lot of data, and the problem is inevitably you're going to end up with many variables. And some of these are going to be really highly correlated as well. So if you think about the demographic data set, you might be looking, and I'll just use the US ACS, American Community Survey, as an example. You have population age bands by gender. So you have the population for, I think, the bands go, there's men 20 to 21, they have women 20 to 21, they have 24 to 26. I can't remember the specific ones, but they have all of those together, sort of broken out. And you can see that there's a few correlations that could potentially happen. Is if there's more people in that area, it's going to be highly correlated to the total population in the area. And you're also going to start to see that, those bands are going to be kind of correlated as if there's more younger people in those areas, there's going to be correlation between the younger age bands. And that applies to things like the income data, that could apply to spend data. All these different pieces start to play a role in terms of, once you've enriched your data, how do you sort of filter out that correlation? And you could end up with, thousands or hundreds of thousands of features, not hundreds of thousands, hundreds or thousands of features potentially on a single for a store location. So we need to bring that down and use the most relevant features. So we want to sort of avoid the curse of dimensionality. So feature selection is going to be really critically important here. There's a few different methods that we've used. I like the lasso method quite a bit, and I think it's, like I said, it's critically important to actually perform that because there is a natural dimensionality of spatial features, and we need to filter out and bring in just the best features that we really want to focus on through this process to really start to understand what's going to happen for these different investments. And ultimately, you want to limit, the number of features to really the key correlations that are happening. So this is analysis from a very similar sort of retail use case that we're looking at, different metrics and different data points here. And you can start to see that while there is some strong correlation, once you actually run the model, there's a few things that are really driving the revenue or performance of these locations. And it's things like number of households, the sales score, which is from MasterCard data, total population, median income, and then a few other sort of trailing variables that, while important, may or may not have an impact. So like we said, we don't know what these top few are really going to be. Once we start the process, it could be the spend in an area, it could be competitors, it could be demographic variables, it could be our left turns are making an incredibly impactful, impact on the revenue performance of a location. So we need to really focus in and start to use those and these two methods by creating the feature selection, and then actually once we run the model, choosing and paring down our features is going to be very, very critical. So this is one key recommendation. And it's kind of tricky because you have to cast a wide net and then limit a lot of the stuff you already built into the model. But ultimately, that can help you create and use spatial data in a more effective way. So some different modeling techniques to actually predict performance with spatial data. These are ones that our teams have used quite a bit and have found to be impactful, like I said, specifically with the dimensionality of this data and using them to kind of correlate and find these different matches between spatial data and performance. So one is on regression kriging. This can help boost your model performance for many spatial use cases, and it's a spatial kriging model that sort of helps to smooth out some of the distribution in the field sample data. It's actually used in a lot of different spatial use cases beyond just prediction for retail and things like that. It's used in soil samples and a lot of geologic sort of use cases. So you can read more about it, but it's actually can boost the model quite a bit here, which you can see if we are just running a simple random forest regression on some data. If we add hyperparameter tuning and we add regression kriging, we actually make some significant gains in our model there as well. So it's something to think about as adding to the model. There's some different Python packages to use for this, but it ultimately kind of helps you add some different insight into the model. It can actually boost your performance quite a bit. So next is actually, once you have a model you predicted for a physical location, right? We know the revenue for a specific space. What do we do and how can we answer that for areas we want to expand into or areas we don't have a store in? And we'll show this demo a little bit later, but ultimately it's the question of white space, right? And we get asked this, it's sometimes called greenfield analysis. But ultimately what you can do is how can I take a model that's applied or data that's applied to a specific store and spread it correctly across space. And there's a few different ways to do this, but you can ultimately start to look at and maybe use a geographic area as a proxy. Now, we've created these trade areas and they're going to be much larger than your standard census block group or your standard trade area. And it's kind of trading off how you can analyze this. So in this use case, we actually just use the census block group as a proxy. And we use the same spatial data from our original model, and we ensure that that data is also at the block group level. And with that, we can actually use our model for the store predictions to create a prediction across every block group in space. Now, like I said, the trade areas traditionally are going to be much larger, compared to the size of a census block group. But with that said, it's about sort of effectiveness and speed to insight. And when I say that is that you could, in theory, run a drive time or create a theoretical trade area for every block group, that you're analyzing. But at a certain point, you're going to run into performance limits to run, for maybe there's, tens of thousands of block groups in an area that you're studying. It's going to take time to create those trade areas, enrich all of them, and pull them in. Whereas if you can keep the data that you already have at the block group level, you can skip all those steps and move forward. And once you hone in, or the users can pick a study area that they want to focus on, you can do that more detailed insight after the fact. This allows you to do that effectively and quite quickly. Now, a lot of use cases, or some of you might be saying, well, I don't know how much these stores make. I have no clue what they do. There's a few different methods that you can use. So you can use these different indicators to see, what's the spatial sort of impact around this area. So like we said, you could look at spend at a specific location, or in that area or census block or block group, to see how much money is being spent, and you have an historical basis for that. You can also look at visits to those locations, and then you can also even just see just if you don't even have any of that data, pure demographics can tell you something about those stores and who the audience is for those locations. And you could use some different clustering techniques to sort of categorize or understand what the stores are based on those trade areas. So you have a lot of options here, even if you don't have that data, to say, what do these stores look like, or what are similar stores to these, just based on these spatial variables that you bring in. And then from there, can you categorize them? We think these are high performers. We think these ones might be low performers. And even within that, add some nuance to start to tell you, okay, this is what this store's footprint looks like, and how can I actually infer that and use that information to make some sort of decision. So how do we apply this across different financial services practices and use cases? These are some different use cases that we've seen and we've worked on. So on the left, you have private equity. Now, usually this is a fast-paced sort of analysis where you're analyzing a new investment. You need to make a decision quickly, often in days and weeks. And you want to understand, okay, how are these locations over or underperforming? And how can I, actually analyze them to say, what does that look like for any new investment that we would make? How would we optimize the footprint? And then how would that sort of impact potential return on investment? And like we said, having a practice set up to do this very quickly, bring in data, enrich it rapidly, run it through some simple modeling, and then also applying that off to, looking at a wide range of different, white space or expansion or, sort of merging of stores use cases is really important because of the fast-paced nature here. Now, generally, private equity, if you're analyzing investment, you will have some metric around performance data. Sometimes at the store level, oftentimes it will come in at that level. So you're starting from a point of having a lot of data, but you need the infrastructure set up to move very quickly in these cases. Now, if you're simply on the equity side, you're validating claims by a company that, about maybe their coverage or their performance, or they're, making plans to expand into California because they believe they have the room to expand there and have a footprint. You want to look at those claims and study them to really understand if that's viable or not, and then, make some sort of inference on how the company is going to perform over the next quarter or several quarters. So what this allows you to do is actually, you don't have that performance data at the store level. So using some of those clustering techniques or seeing where those stores are could potentially, help you do that. And then actually looking at, potential white space. So that use case of expanding to California, are there a lot of competitors? Is it a dense space? Does this make sense for them? Do they have the infrastructure set up or the distribution centers to, actually expand in those locations? And the distribution center is actually a really interesting use case, because if a company is buying a distribution center or looking to acquire one, you can actually look at those areas and say, okay, how does this expand their coverage? How many, new cities or towns could they potentially expand into? And how many stores might they be opening? And what does that investment look like? And what does that potential return on investment look like for them? The last one is I call it environmental, but it could be any sort of event use case. And obviously we're living in one of these crazy event times right now. So, like I said, understanding the economic recovery angle is going to be really key and critical. And that's something, that we'll be studying, and there's a lot of data to support that. But things such as a natural disaster, if you think of a large hurricane or power outage or some of these things that may have happened, how can you understand the performance of that over time? And you can actually, use some of this data, maybe foot traffic data, to actually look at and study where there's a decrease in traffic to these stores. How long was the decrease in traffic, or how much the spend went down over time? And then ultimately, whose footprints are most exposed to that? If you think of the Texas power outage, there are footprints that are overemphasized in Texas. What stores are going to be impacted by that? And which ones are going to be potentially exposed to some difficulties because of that. But there's also the studying long-term viability of store footprints, and we hear a lot about this in terms of understanding climate change, who's potentially exposed to that over time, and how might that impact their performance. And this is sort of a long-term thing, but I know a lot of different firms are starting to study this as well. So the last step, like I said, you want to make sure that your insights are exposed to the entire organization. So how do you do this? I think repeatability is critical. How will I do this again for the next project? Like I said, in a private equity use case, if you have a ability to run these models in the matter of days, you have to work in between those to set up the infrastructure and the modeling and the processing to do that over time. So when the next project comes in, I know what I need to do. I have the some different code or pipelines or things like that set up to support this. How can analysts and other teams access these insights and other data over time? So as you're creating this data, you're creating a wealth of information about these different stores. How can I share that information out so people can use them to study independently and not have to come with questions, but maybe use the data to bring up new questions? What's the best way to deliver these insights? Is that it's a common question we have. Excuse me. Which is actually how do you present that? Is that a dashboard? Is that a application? Is that a map? What is the best way to deliver these insights? That depends on your teams and who you work with, but also a valid question to ask. And then what are the additional data points that I'm delivering outside of this? Like I said, if you enrich your store footprints with all this data and information, you have information about these different competitors as well, about who's coming to these different stores, about demographics. Can you share that information out so more people can sort of make use of that? And then, like I said, ensure repeatable pipelines for enrichment, feature selection, and modeling as you develop these projects over time, making sure that you can really repeatedly reuse these, some of the code or the modeling that you developed, and make sure that it's, when the next project comes, you can actually continue to reuse that. So having this sustainable process to pull from is really, really important. I can't stress that enough, is that when you need to work quickly, having something to fall back on that's ready to go is really, really useful. And then the final piece, like I said, design solutions that are easily accessed by non-data scientists. And if you're working in the context of a notebook, think how other people might want to access that. Is that a simple dashboard that's developed? Is that an application? Is that reports? What does that look like? And this sort of develops, or sort of highlights the space a little bit, where, if you're a GIS professional or data scientist, we're small but growing sort of market, but there's many other people outside the data analysts, that may want to access data in a different format, developers that might want to use data that you're is sort of putting out to put into an application. So these groups are, very wide, and I think it's also be cognizant of the teams you're working with to really start to share those insights in different ways. And I think that's really important. The final one that I'm going to share is leveraging a cloud-first approach and using modern data warehouses, because the data warehouse space is expanding quite a bit. There's more and more tools that are actually being pulled into these data warehouses from different modelings. You can do ML on a data warehouse, and you can store massive amounts of data over time. And if you set up the right data infrastructure and you have the right tools on that data warehouse to do these things, you can actually build very repeatable pipelines even at the data level. And as you pull new data in, you're ready to do that modeling quite quickly. So I know a lot of times it's easy to think in the context of a notebook, but doing analysis where the data lives and preparing the data in effective ways and doing some of these pieces on the data warehouse as much as you can actually help speed up your pipeline and get you to the modeling faster. So if you have the right data infrastructure and you have the right tools at that level, I think it helps you over time to get that sustainability that we're talking about. So the last piece is sort of what this looks like in practice. I actually opened the link here, so we should be good to go. I showed this earlier on in the demo. This is actually a map of Los Angeles, but we have, this data is over the entire US. And what we can actually do is we can actually look at individual stores. These are target locations with sort of, we modeled some fake revenue data for these different locations. And ultimately what we can do here is we can ask the question of, okay, for Los Angeles, if we have all these different stores, where is there room to expand our footprint? And what I'm going to do is I'm just going to limit this analysis to Los Angeles. And there's a model running on the back end that actually runs a complete, a complete predictive model across this set of stores. And we're only going to focus on stores in LA at the time. So This allows me to choose these features that I want to include into the model. We'll include everything for right now, but you can also give people the choice to say, here's the variables I care about, and here's how I can interact them. So going through what we just talked about, the feature selection step is really important. How can we run and use that over time? So we'll create our model. We can see that there's all these different metrics that are driving the performance of these different locations. So there's a lot of different competitor or sort of spend in these different areas, financial scores, expenditure, household expenditure, things like that. Now, what we're going to do is do the same thing but for white space, and we're going to run this and run it for every block group within the Los Angeles. It's the CBSA, if you're familiar with that area, but effectively the metro area for Los Angeles. And what's going to come back to us is actually a set of block groups that are going to be styled, and on the back end here, we're using the same model we did for the stores. Instead of doing it at the 10-minute drive time, we're doing it at a census block group level. And then we're also running a Moran's eye off that to actually cluster these stores and filter them to see where we can go from there. And very quickly, because I'm coming up on time here, once we have our block groups here, I can actually say, okay, I want to select the high clusters or the high potential revenue block groups. And then I can actually start to focus in on where those are. And I, of course, don't want them near current stores. We're looking for white space. And once we see and filter those areas, we'll see a few specific areas pop up, but there's a few cross LA here, but one that's really showing up is that there's a large cluster in Long Beach here. And you can see that there's, different, potentially a lowest quantile prediction for revenue is 45,000 up to 60,000. And that carries across most of these as well. So you can start to see where there's actually revenue. And once I have this here, I can actually say, okay, there's potential for a new store location here. Where might I put it, or where is there available real estate, or what does that look like? But I can also do that across the, for different metro areas in the entire US and expand it from there. All this is using a model that we've developed, we've hosted on the back end, but you can see it's very accessible for maybe a non-data scientist or analyst to actually use all this. And you still have this wealth of data that we've pulled in from here as well for them to continue to use over time. So I'll wrap it there because I think I'm 1 minute over, and thank you all for joining.
Thank you very much, Matt. I think we do have time for one quick question. We had a question from Michael Hansen. He said, in PE funds looking at retail assets, is it typically an analyst or an associate starting to use geodata for the first time? Or are those funds typically going and hiring data science and geospatial talent outside of the firm?
I've seen both. It really depends. I mean, some firms have a data science team that's built up, and they're sort of already working with a lot of different data science use cases beyond just geospatial, right? So geospatial becomes a part of their practice or things like that. But I think I've seen at the analyst and even the associate level, just using very simple spatial data to maybe look at some sort of asset analysis. And the example here would be distribution centers. If you know that a new store is opening a distribution center, they feel like they have a range of 400 miles. You can look at to see how many stores they have in that area. That's a pretty simple point and polygon analysis. And you also know maybe they target small towns. How many small towns are within that area, or cities of population under 20,000? You can say, hey, maybe they have the potential to expand into 2,000 towns within this new trade area. That represents something really a great opportunity for them. There's not much competition, and what does that tell you about what's going in there? So we get it. We're kind of going deep into the modeling today, but there's even some of these higher level analyses that you can do as well at any of those levels.
Fantastic. I think we can squeeze one more question because it's a great one. Anna Gomulka, thank you for your question. She's asked, young professional working in environmental GIS data analysis, perhaps you want to transfer to retail investment analysis. Any recommended resources, courses, or anything?
Yeah, there's a lot of great assets on our CARTO blog, which I don't want to shameless plug it. We do a lot of this stuff all over time. I think there's a wealth of information on different courses like Udemy and Coursera. There's a lot of great courses there just to give you some fundamentals in this stuff. And then I would also really use your basis in terms of studying environmental factors and apply that to start to understand how people interact with retail or physical assets. And how things work in the environment and the factors that play there. It's sort of applying the same sort of subject matter expertise to retail or things like that. So if you can start to think about why would someone go to this location versus that location? What are the data points that would drive to that? Using that same spatial knowledge you have, just applying it to a different use case can help you, kind of make that leap as well. So.
Fantastic. Thank you for the answer, Matt. Great. Well, Matt, we'll leave you to your day. Thanks for joining us. Now really happy that we're going to be moving on to the next section.